Okay, so I hope you have fun exploring what's happening with the end behavior and specifically with asymptotes. Is actually what we were just playing with in the last one. And this time you don't have to discover anything. I'm going to tell you stuff. So we're going to talk about even and odd functions. So we know about even and odd polynomials, which are really easy to determine. You're just looking at the highest degree of the exponent and deciding, hey, that's an even number. It's even. But with even and odd functions, that's totally different. So we have x squared, which is an even function. And here it is. And we've got 1 over x, which is an odd function. We're just telling you that. And this one, f of x equals x minus 4, quantity squared, is neither. So why? Specifically the neither. So here's an even function, here's an odd function. This one is neither. So when I talk about even functions have symmetry across the y-axis. So that's why this is even. The reason also, when I plug in 2, I get 4, but when I plug in negative 2, I also get 4. When I plug in 9, I get 81. When I plug in negative 9, I get 81. Or in other words, in an even function, f of negative x is equal to f of x. I get the same thing when I plug in a negative number as when I do when I plug in a positive opposite. So that's an important definition of even, and we'll spend some time with this algebraic definition. And then we have our symmetric around the y-axis. And it's what kind of symmetry? It's reflectional. Symmetry around the y-axis. Okay, so that's an even function. So the reason this is not an even function, while it is an even polynomial, it's not an even function because it is not symmetric around the y-axis. When I plug in 1 into this function, I get 9. When I plug negative 1 into this function, I get 25. So f of 1, negative 1 is 25, and f of positive 1 is 9, and those are not the same things. So to be even, they have to be exactly the same. So that's why it's not even. Let's talk about why it's not odd now. I wanted to clear everything, and I just did. La, la, la. So let's look at this odd function. So this is an odd function, 1 over x, and it also has symmetry, but it has rotational symmetry. So rotational symmetry around the origin. Let me explain what I mean by that. So here is the same function. Picture the same function, but movable now. When I spin this around, other than my numbers being upside down, the function is identical. And so it has rotational symmetry. And not quite perfect, but it's good. It's not working. Actually, it's... Oh, that's... Just kidding, this is upside down. That's what the problem is. It's upside down. I brought a new one in. So, there it is. And when I spin it, it is the same. Not as the one that's in the picture. The one in the picture is funky. I completely forgot about that. I didn't fix it for you. And you can tell, picture in your book, see how the numbers are backwards? This is actually 1 over negative x in your book, if you want to think about that. 1 over negative x happens to also be an odd function. So it's okay, it's still an odd function, but it's not the same odd function. All right. So we where saying that it has, where'd the words go? Rotational symmetry around the origin. And let me put this image back to normal. That's what the image is supposed to be. And I hope I fixed that, but if I didn't, it's supposed to be this one. The other reason it's odd is also algebraic. and we're still talking about this function here, when I plug in negative x, I get out the opposite of the what I get when I plug in positive x. So when I plug in 1, out comes positive 1. When I plug in negative 1, out comes negative 1. Or when I plug in 5, out comes 1/5, and when I plug in negative 5, out comes negative 1/5. Another good example of an odd function is x cubed. So if you think about x cubed, um, when I plug in a negative 3 into this, so negative 3 cubed is negative 27, but 3 cubed is positive 27, so they're the exact opposites of each other. So the reason this one, I know a lot of people don't try to think this as an odd function, but it's not odd because when I plug in a positive 3, I get out 1. When I plug in a negative 3, I get negative 7 squared, which is 49. And so they're not exactly the opposite of each other. So that's what makes something odd. So with that in mind, in your own words, answer question 2. And you can back up the video and use the words that were just there. A function is even if it has reflectional symmetry around the y-axis, and this is important, f of negative x equals f of x. Make sure you understand what that means. That's probably a more important definition. A function is odd if it has rotational symmetry around the origin, and we're going to use g here for just to not use the same letter, but g of negative x equals the opposite of g of positive x. And that's really important. So those are our two working definitions. And then we're going to go ahead and try to classify. So pause the video, take a minute, back up if you need to, write down the definitions if you didn't already. All right. So here's some functions. Based on what we just defined it, can we decide what these are? And so we can look at, we have some tables here. We have some equations. We have some images. The images are going to be easier so that you can think about what happens if I turn it. You can actually turn your book upside down for rotational symmetry. For reflectional, you can think, what if I fold this? What's going to happen? So pictures are really cool. You can always go to Desmos and graph stuff, but it's important to be able to know without the graph because you won't have full access to your calculator all the time when making these decisions. So you need to know. So I'm going to go ahead and write down the answers in just a minute. I want you to pause the video and decide. And I'll have the answers pop up in about, I don't know, 10 seconds or so. So pause it before they show up. Okay, so I've just written down words. We have two neithers, B and H, and 4 odd, 3 evens, A, E, and C. 4 odds, D, G, F, and I. I'm going to show you with I the algebraic definition. So f of negative x. So we're going to plug in negative x. So negative x, parentheses, negative x minus 2 times negative x plus 2. Now you can do this with numbers, and a lot of people find it easier to do with numbers. Like I'm going to plug in negative 3, and I'm going to plug in positive 3 and see what happens. That works, but sometimes it's not perfect, so I always tend to do the letter definition because I'm kind of crazy like that. So at negative x, I'm going to pull out the negative 1 from this. So times negative 1, x plus 2. I'm going to pull the negative 1 out of this, negative 1, x minus 2. So I've got negative x, negative 1, so that's negative x, and then x plus 2 and x minus 2. And you'll notice it's exactly the opposite with this negative sign right here of the original. Notice these two switch signs. That's the exact opposite. And so that's how we can algebraically decide. Let's continuing with this one. Let's jump to Desmos really fast and see if we can see visually why it is odd. So Desmos, and while we're getting that up, we'll drag this over here. We had x parentheses x minus 2 and x plus 2. And as you can see, rotational symmetry, just getting to clean it up a little bit, completely exists here at the origin. You have this value is the same as that value is the same as that one. Opposites are everything's the opposite. It's going to flip around and turn out beautifully. And so you can look at a picture and decide, or you can do algebra and decide. It's up to you. And that's what we're talking about with even and odd functions. I will talk with you tomorrow and clarify any questions you might have. Have a good day.